Greetings and welcome to Lecture 8.1, Definitions and Common Roots. We've already tackled some squaring. For example, if I wanted to solve what the length of this dashed line is for the square, and my square is 1 inch by 1 inch, then I can use Pythagorean Theorem to tell me that C equals 1 squared plus 1 squared. Well, 1 squared is 1, 1 squared is 1, so 1 plus 1 is 2. So C squared equals 2. Now C is the positive square root of 2. So if I took the square root of C squared and took the square root of 2, then I would find out what C is. C is the square root of 2. So let's talk about a little bit more. And we will get into this golden rectangle at the end of the lecture, but I'll continue to explain what the golden rectangle is and further down the line. So let's keep going. Square roots. If we wanted to know the square of 5, we would write 5 squared, which is 5 times 5, which is 25. Now we're going to do the reverse action, and from the square of a number, we're going to go back down to the number. Since the square of 5 is 25, we can say 5 is the square root of 25. And our notation looks like this. It's this interesting bracket shape over 25. That's called the radical. So radical 25. In the expression 25 is called the radicand. So the whole entire expression is called the radicand. This marker is called the radical sign. And the 25 is called the radicand. The number inside the radical bracket is the radicand. The symbol is the radical sign, and the complete expression is called the radical. Now, what we're going to focus on is the positive square root. There is a negative square root as well. If x represents any positive real number, then the expression square root x is the positive square root of x, or it's called the principal square root of x. It is the positive number we square to get to x. Now, this is something where I'm going to disagree a little bit about the book we are using. Let me continue to explain what the negative square root and how we are going to have the notation of it for your homework and for the rest of the chapter. The expression negative square root x is the negative square root of x. It's the negative number we square to get to x. Now here's why I disagree with this. 3 times 3 is 9. The square root of 9 is 3. Negative 3 times negative 3 is 9. Therefore, the square root of 9 can also be negative 3. And in higher levels of math, we will both recognize the positive and negative square roots just using the one symbol. For the book, if we want the negative number of the square root, we'll put this negative out front. But just recognize that negative 3 times negative 3 is 9, as well as 3 times 3 is 9. So the square roots of a positive number. Every positive number has 2 square roots. One is positive, and one is negative. The positive square root of 25 is 5, and can be written as the square root of 25 equals 5. The negative square root of 25 is negative 5. And it can be written as negative square root 25 equals negative 5. Again, this is where I disagree. Mathematically, the square root of 25 can be plus or minus 5 without this negative symbol out front. But again, for your book and for your homework, we'll leave it as the negative out front. The reason why I'm even explaining this is because I don't want you to get to a higher math and say, oh no, the square root of 25 is always 5. No. There are 2 answers just to this equation. The square root of negative 25 is positive 5 and negative 5. just to continue, for this chapter, for this level class, we will distinguish between the positive and the negative. Right? But in future classes, we'll use both of the roots using just the single symbol. So let's find the following roots. The square root of 36, the negative square root of 36, and we'll do the square root of 144. So think about two numbers, one number multiplied to itself will equal 36. Well, that's 6 squared, so 36 is 6 squared, so our answer is 6. So the square root of 36 is 6. The negative square root of 36 is negative square root of 6 squared, therefore it's negative 6. And lastly, the square root of 44, well, 144, we can write it as 12 squared, so the square root of 12 squared is 12. Now, all of those examples, what came out of the square root was a whole number. So the square root of 36 is 6, the square root of 144 is 12. It's a whole number. But every single number we could take the square root of. So the positive square root of 17 is written as square root of 17, and the negative square root of 17 is written as negative square root of 17. But 17 is not a perfect square. It's not the square of an integer, meaning it's not 3 times 3 or 4 times 4. Okay, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25. It's somewhere in between 4 times 4 and 5 times 5. So what we do is we go ahead and list its square roots as negative 17, and the negative square root of 17, they're irrational numbers. For example, let's look at a few. Number 9, the positive square root is 3, the negative square root is negative 3, and it's rational. Right? It's a whole number that comes out, so it's rational. 49, square root is 7, the negative square root is negative 7, and it likewise is rational. It's a whole number that comes out. Square root 5. Well, the square root of 5 is square root of 5. The negative square root of 5 is negative square root of 5. It's an irrational number. A whole number does not come out of it. And it's an irrational number because if we tried to find the decimal value of this, we never would be able to stop. That decimal continues and continues and continues. Square root 23. Well, again, it's not a rational number when we take the square root of it. So it's negative 23. The negative square root is negative square root 23, and it is an irrational number. 100. Well, the square root, the positive square root is 10, the negative square root is negative 10, and it is a rational number. I do want to talk about something very special. The square root is 0. The square root of 0 is 0, and it is the only real number with one square root. That is not positive, and it is not negative. Right? 0 is just 0. And the last bit of square root information is square roots of negative number, like the square root of negative 3. That means the negative is inside the radical sign. Well, negative numbers have square roots, but their square roots are not real numbers, and we are only studying real numbers, so we're not going to consider the square roots of negative numbers right now. When you get into higher level math, you will consider the square root of negative numbers. And they're actually called that they're in the complex plane, and they are complex numbers and not real numbers. So far we've concentrated on square roots, but there are lots and lots of other roots possible. So we have the cube root of a number. That means it was raised to the third power. And to get the original number, we go backwards. The cube root of 8 is 2. Why? Because 2 cubed is 8. The cube root of 27 is 3. Why? Because 3 cubed is 27. How we write that is we use the same radical sign, but right in between the little hook, we put what root we're doing. If there's nothing there, it's an implied square root. If there is a number there, that's the root we're taking. So this is the cube root of 8, which means that it's 2 times 2 times 2, so it's 2 cubed, therefore 2 is our answer. Likewise, the cube root of 27, well, that's 3 cubed inside there, so 3 comes out. Now, here's the thing. An odd root, like 3, 5, 7, can have negative outcomes. Even roots, like square to the 4th to the 6th, it does not have negative outcomes. We're not doing that this class, remember? So, for example, the 4th root of 16 is 2 because 2 to the 4th is 16. The cubed root of negative 27 is going to be negative 3 because negative 3 times negative 3 times negative 3 is negative 27. So just keep that in mind. There are a lot of common roots that I think that you should learn. Definitely memorize and put it into your math bank, memory bank. If you know these, math will be a lot easier for you to work with square roots and such. So let me just run through these very quickly. Square root of 1 is 1. Square root of 4 is 2. Square root of 9 is 3. Square root of 16 is 4. Square root of 25 is 5. Square root of 36 is 6. Square root of 49 is 7. Square root of 64 is 8. Square root of 81 is 9. Square root of 100 is 10. Square root of 121 is 11. Square root of 144 is 12. And you could also throw in the square root of 169 is 13. And here's why, if you memorize these, or if you learn them and get them into your long-term memory, here's how these can be very helpful to you. Let's say I say, give me the square root of 10. Well, the square root of 10 is not a perfect square root. It falls somewhere between the square root of 9 and the square root of 16. So it's somewhere between 3 and 4. But I do know it's not a perfect square root, therefore I can leave it as the square root of 10. I'm not looking for a whole number to pop out. Several common cubed roots are the cube root of 1 is 1, cube root of 8 is 2, cube root of 27 is 3, cube root of 64 is 4, and the cube root of 125 is 5. Remember, cube roots and all odd roots can have negative components, and the radicand can be negative. So the cube root of negative 1 is negative 1. Cube root of negative 8 is negative 2. Cube root of negative 27 is negative 3. Cube root of negative 64 is negative 4. And the cube root of negative 125 is negative 5. Fourth roots, you should know, is the fourth root of 1 is 1. That's always an easy one to remember. It doesn't matter what root it is. If it's the root, some root, the 100th root of 1 is 1. The fourth root of 16 is 2. Fourth root of 81 is 3. Fourth root of 256 is 4. And the fourth root of 625 is 5. So those are very common. And if you kind of get them into your memory bank, you'll be able to do math a lot faster and easier if you have those handy. So that's it for part 1 of this video. So until part 2, be seeing you.